Hello everybody, welcome back. For today's lesson, part 1 is going to be practicing with the graphing that we've been working on the last week. And in addition to graphing, we're going to be going over period, amplitude, and domain and range. And so that's part 1. And then part 2 is going to be new information about transformations of trig graphs. Okay, so what I would encourage you to do for part 1 is to pause the video, graph it yourself, figure out the period, amplitude, domain, and range, and then resume the video and see how you did. And then you can do that for all 6 problems. Okay, for number 1, we're going to graph y equals sine of x over the interval from negative 2 pi to 2 pi. So go ahead and pause now if you're going to practice on your own. And what I would do is I would go ahead and just make my axes, and I would make a mark at 2 pi and a mark at negative 2 pi. Remember, 2 pi is equivalent to 360 degrees. So if you're going from 0 to 2 pi, it's like you went around the circle one time. It's like you went a full time around through quadrant 1, quadrant 2, quadrant 3, quadrant 4 around the unit circle. Okay. Now we take the interval from 0 to 2 pi and we break it in half, and then we break each half in half. Do that with the interval from 0 to negative 2 pi. Break it in half and break each half in half so that you have 4 equal chunks. And then you have a mark at 1 and a mark at negative 1. Okay, so for the sine graph, we're going to go through 0, 0. So starting there, you go from the middle to the top, to the middle, to the bottom, to the middle. There's one complete sine curve. Same thing on the other side. We're at the middle, to the bottom, to the middle, to the top, to the middle. And if you are drawing it on a particular interval, then you have to stop at the endpoints. So don't draw it beyond and put an arrow. I know that the entire graph does go beyond that point, but if you're given an interval, that means stop here, stop there. Okay, so what's the period? Remember, the period is the width of one cycle, and the width of one cycle was 2 pi. So the period of the sine graph is 2 pi. What's the amplitude? The amplitude is the distance from the center to the top, so that distance is 1. So the amplitude is 1. What's the domain? And when stating the domain, consider the entire function, not just the given interval. So this would just continue indefinitely as x goes toward negative infinity and x goes toward infinity. It's just going to keep going. It's oscillating up and down, up and down, up and down. So the domain is all real numbers, and you're welcome to say that as negative infinity to infinity if you want to use interval notation. And then what's the range? So what y values do we notice this graph is going through? It's going up to a height of 1 and down to a height of negative 1. It does touch 1 and it does touch negative 1, so we would include those in the endpoints. We would include negative 1 and 1. So using interval notation, we have the interval from negative 1 to 1, or if you want to use inequalities, you could say negative 1 is less than or equal to y is less than or equal to 1. Okay, let's move on to number 2. We're going to do the same thing for the cosine graph. So if you want to, go ahead and pause and try it yourself, and then resume and see how you did. So I'm going to make a mark at 2 pi, a mark at negative 2 pi, a mark on the y-axis at 1 and negative 1, and between 0 and 2 pi, I'm splitting that in half and splitting each half in half. Same thing between 0 and negative 2 pi, split in half, split each half in half, so that we have 4 equal parts. The cosine graph goes through the point 0, 1, so we start at the top. So we go top, middle, bottom, middle, top. Same thing on the other side. We're at the top, then middle, then bottom, then middle, then top. And then we're going to connect that. Make sure you make it look a little curvy on the end. I'll show you what not to do when I get to the other end. So sometimes people do this. They make it look straight at the end. See what I did there? That's not what you want. You want it to look like it's curving and about to curve back down the other way. So kind of like that. And again, don't go beyond those endpoints. Yes, the graph would continue infinitely far, but if you're given an interval, then you need to stop at those endpoints. All right, the period, again, the width of one cycle is 2 pi, just like it was for the sine graph. The amplitude, the distance from the middle to the top, the distance from 0 to 1 is 1, just like it was for the sine graph. The domain, just like for the sine graph, this would just continue to go on infinitely far to the left and the right. So it's from negative infinity to infinity, or if you want, you can say all real numbers. And the range, you can see the y values are going from a height of 1 to a height of negative 1, just like they were for the sine graph. So the range is negative 1 to 1, or negative 1 is less than or equal to y is less than or equal to 1. Okay, let's move on to number 3. We're going to do the same thing for the tangent graph. Go ahead and pause if you want to practice it yourself, and then resume. So for the tangent graph, we are still going from negative 2 pi to 2 pi. Make a mark at pi. Also make a mark at pi over 2. You might want to label that one because pi over 2 is significant. That is where you have a vertical asymptote. So let's put those vertical asymptotes in place at pi over 2, at 3 pi over 2, at negative pi over 2, at negative 3 pi over 2, and so on. They are pi units apart. And then remember the tangent graph goes through 0, 0. So you have a 0 halfway between each set of two asymptotes. And then if you want to start by putting that center curve in place, and then just replicate it over and over again. And then if you have to stop at the endpoint 2 pi, you're only going to have half a curve over there, and then on the left, half a curve over there. Okay, for the period, the width of one cycle is just pi. From x equals negative pi over 2 to x equals pi over 2 is a width of pi. And the amplitude, the distance from the center to the top, well, there is no top, it just keeps going, so there is no amplitude, we say undefined. The domain. This will be a little bit trickier because we have all those places where we have vertical asymptotes, and so there's no x value there. There's no x value at pi over 2, at 3 pi over 2, at negative pi over 2, negative 3 pi over 2, and so on and so forth. So we need to skip over those in our domain. So what we could say is x is not equal to pi over 2, 3 pi over 2, 5 pi over 2, etc. But there's a more efficient way to say that because we can't list them all. There are infinitely many of them. So here's what we can say instead. X is not equal to pi over 2 plus pi times n, where n is an integer. So what that means is we're saying x is not equal to pi over 2, x is not equal to pi over 2 plus pi times 1, that would be 3 pi over 2. X is not equal to pi over 2 plus pi times 2, that would be 5 pi over 2, etc. So this is a way to represent all of them. And then for the range, notice that the graph goes all the way down to negative infinity and all the way up to infinity. So we have all real numbers for the range. All right, let's take a look at the cosecant graph. Pause the video if you want to graph it for yourself. We're going from negative 2 pi to 2 pi. Go ahead and put a 1 and a negative 1 on your y-axis. Remember, this is the reciprocal of sine. Let's go ahead and break these intervals into chunks, 4 equal chunks between 0 and 2 pi, and 4 equal chunks between 0 and negative 2 pi. Okay, the sine graph goes through 0, 0. That means the cosecant graph is undefined there. So vertical asymptote everywhere that sine is 0. So you would have vertical asymptotes at 0, at pi, at 2 pi, at negative pi, at negative 2 pi, and so on and so forth. The sine of 90 degrees is 1. That means the sine of pi over 2 radians is 1. That means that we would have this point right there if we were on the sine graph, and the reciprocal of 1 is 1, so cosecant of pi over 2 is also 1, so we're still at a height of 1. And remember what happens from there is we get curves that go up. And then in the next section, we have a point at -1 and curves going down. And they alternate like that. Curves going up and curves going down. Those are the reciprocals of the sine graph. Okay. For the period, the width of one cycle would have one curve going up and one curve going down, so that width is 2 pi. For the amplitude, the distance from the center to the top, well, there is no top, so that one is undefined, just like it was for the tangent graph. For the domain, just like we did on the tangent graph, we have to skip over all the places where the function is undefined, so we have to skip over all the x values where we have a vertical asymptote. So that would be at 0, at pi, at 2 pi, etc. So we can call that n times pi, where n is an integer. That would represent 1 pi, 2 pi, 3 pi, 4 pi, 0 pi, -1 pi, -2 pi, etc. And for the range, okay, so what y values is it going through? Well, we have points at a height of 1 and higher. We have points at a height of -1 and lower. So we're going to need to write two different intervals. We go from -infinity to -1. Those are the lower values. Union, we go from 1 to infinity. Those are the higher values. Okay, number 5 is the secant graph. So again, pause and do it yourself if you want to. We're going to go from -2 pi to 2 pi. Put your 1, put your -1 on your y-axis. Break up those intervals into 4 equal chunks. And then remember, secant is the reciprocal of cosine. So wherever cosine is 1, secant is 1. Wherever cosine is -1, secant is -1. Wherever cosine is 0, secant is undefined. So cosine is 1, it goes through 0, 1, so secant also goes through 0, 1. Then cosine is undefined, or cosine is 0 for pi over 2, so secant is undefined. So that puts our first asymptote in place, and then we can just put more and more asymptotes in place, pi units apart. And then we're going to alternate points at a height of 1 and points at a height of -1 until we reach the endpoints of our intervals. And then just like the cosecant graph, we have curves going up and curves going down, alternating. If you have to make half a curve on the end because you're not supposed to go beyond 2 pi, that is okay. Okay, for the period, so the width of one cycle would have one curve going up and one curve going down, so that would be 2 pi. For the amplitude, the distance from the center to the top, well, there is no top, so just like tangent and cosecant, the amplitude is undefined. For the domain, we're going to have to skip over all the places where the x values are, or all the places where we don't have x values, the places where we have asymptotes. And those are pi over 2, 3 pi over 2, the same places they were for tangent. So the domain is the same as it was for tangent. And that was pi over 2 plus pi times n, where n is an integer. We're just going to assume that when we write these kinds of descriptions for the domain, that n is always an integer. So if you don't write that every time, that's okay. And for the range, it's just like the cosecant graph was. We have points at a height of 1 and higher. We have points at a height of -1 and lower. So we have -infinity to -1, union 1 to infinity. Okay, number 6, the cotangent graph. All right, so what we're going to do is pause if you want to do it for yourself. Make your x-axis go from -2 pi to 2 pi, and then break those into equal chunks, but pay close attention to pi over 2. So remember that the cotangent graph is the reciprocal of the tangent graph. And wherever tangent was 0, cotangent will be undefined. That means cotangent is undefined at 0, and at pi, and at 2 pi. So notice that the asymptotes for cotangent are not in the same places as the asymptotes for tangent. They are offset. And in between every two asymptotes, we're going to have a 0. Remember that if tangent goes up, then the cotangent goes down, because if numbers go up, their reciprocals will go down. So we have curves like this. The period is the width of one cycle, so the period is 1 pi. The amplitude is a distance from the center to the top. There is no top, so it's undefined. The domain, we need to exclude all the x values where we have a vertical asymptote, and those are at pi, at 2 pi, at 3 pi, 0 pi, negative 1 pi, negative 2 pi, all the multiples of pi. So x is not equal to n times pi. Let me go back to my previous, slide. I should have said for the domain of secant, I should have said x is not equal to those numbers, not x is equal. So I could have made that mistake on other ones too. I'm going to go back and check. X is not equal to those things. Let's check cosecant. Yep, did the same thing. I should say x is not equal to n times pi. And got it right on the first one. So we're just listing the things x cannot be rather than the things that x can be. Okay, moving on, we've got the range for the cotangent graph, and we can see that it goes up to infinity and down to negative infinity. So we can say all real numbers, or negative infinity to infinity. Okay, so that was supposed to be part 1 of today's lesson, and part 2 is coming, and I'm thinking that parts 1 and 2 are pretty much going to be the work for the week, because my time is running out. I'm already at 17 minutes, and if you did pausing and graphing yourself, then you're probably way over that time. But all in all, for the week, the plan is to get better at this and to learn a bit about transformations of these graphs. Thanks, everybody.